Okay, so here are the formulas for the sum and differences for sine and cosine. So if you have sine of, let's say, a sum of two angles, x and y, the formula is sine of the first angle. I'm going to refer to this x as the first and y as the second. That's the way I learned it when I was 17, and it's just always stuck with me. So it's sine of the first, cosine of the second, and it's plus sine of the second, cosine of the first. So there's sort of like a rhythm or a flow to it. And you notice that this sum here results in a sum here. And notice that I call this the sines and cosines are kind of jumbled together. There's sines with cosines here and sines with cosines here. But if you know that one, you can go to the sign of a difference, because the only thing that changes is when this x becomes x minus y, all you have to do is go exactly the same formula, sine of the first, cosine of the second, minus sine of the second, cosine of the first. And so I always think this one's a little funky because the sines and the cosines are jumbled, but the good thing about it is when it's a sum here, it's a sum here. When it's a minus here, it's a minus here. Now, if we're talking cosine of the first, cosine of a sum, x plus y, well, this one is cosine of the first, cosine of the second. And when it's a sum here, it's actually going to be a minus here. So we're going to go minus sine of the first, sine of the second. And you might be able to guess on the pattern that we've seen when in the sine formula, when this guy turned to a minus, this plus turned to a minus. Well, in the cosine one, when we go to x minus y, the same thing's going to happen. We're going to say cosine of the first, cosine of the second, but it's going to become plus sine of the first, sine of the second. So there are the four formulas, and I just remember that sine was good because the signs are the same, so that you get that s. Signs are the same, so the plus is the same in this one as it is in this one, minus is the same here as it is there. So in a sine of a sum, they're the same, so you get a lot of s's going on there, and the cosines are different. So it's when it's a plus here, it's a minus here. When it's a minus here, it's a plus here. Bad news is the sign, the pluses are the same in both of these, but the sines and the cosines are all jumbled. So it's like there's one bad thing in that the sines and the cosines are jumbled together, but at least the signs are the same. Here the cosines and the sines are grouped together, but the signs are different. So I kind of thought of it that way, where in the sine, the signs are the same, but there's a jumble of sines and cosines, and in cosine the signs are different, but the cosines are with cosines and the sines are with the sines. So if that's all you need of those four formulas, there you go. Just for what it's worth, these things are usually asked in a way, something like they'll say, find the cosine of like 5 pi over 12. And that's not one of the regular angles that's on your unit circle. But what you're supposed to realize is that you can write 5 pi over 12 as 3 pi over 12 plus 2 pi over 12. And both of those angles are angles on the unit circle. 3 pi over 12 is pi over 4, and 2 pi over 12 is 1 pi over 6. So if they were to ask you to find the cosine of 5 pi over 12, you'd have to realize first that you can break it into 3 pi over 12 plus 2 pi over 12, then realize you can reduce both of those to pi over 4 plus pi over 6, and then you say, okay, well, let's go to my formula. I've got a cosine here, so I know my cosines are together. Cosine of the first, cosine of the second. But in the cosine one, the signs are different, so that plus there is going to become a minus here. And I'm going to go minus sine of the first and sine of the second. And then all four of these numbers here, so sine of pi over 4, cosine of pi over 6, sine of pi over 4, and sine of pi over 6 are all numbers you should know from your unit circle. Cosine of pi over 4 is root 2 over 2. Cosine of pi over 6 is root 3 over 2, minus sine of pi over 4, which is root 2 over 2, and the sine of pi over 6, which is 1/2. So these two guys, when you multiply them, a root 2 times a root 3 is a root 6. And in the denominator, 2 times 2 is 4. So I get root 6 over 4 minus root 2 times 1 is just root 2, and 2 times 2 is 4. And because I've got subtraction of two fractions, I'm lucky because I already have a common denom, and so I can write that as root 6 minus root 2 all over 4. And that would be like your answer. So whether your quiz has just the formulas, which are these four guys, or you have to actually use one of them, I don't know, hopefully you don't, but that they all come down. They're always going to be these whatever angle they give you in here, it's always going to be something that you can break into two angles that you do know. So hopefully that my little method that I learned when I was 17 about the sines being the same and the cosine, the sines are different, hopefully that kind of works for you and you can memorize this stuff. Good luck.